Hello, everyone. Welcome to my presentation. Here I'm going to talk about STAT580 individual project, and my name is Yuqi. Now we are going to describe what is our project. Neil is a realtor who wants to understand whether one could develop a model to predict the sale price of a house in his region. He recruited 3 high school students to scrap different online resources and collect data on past sales on 3 neighborhoods. There are 3 neighborhoods: College Circle, Edwards, and Old Town. Neil is seeking for your help to build a predictive model using the data set. As a statistical consultant, my job is to predict the house sale price for the house with the missing house prices. Neil has separated data files for each of the neighborhoods. Additionally, he has managed to separate these houses with the missing sale price into different data files. And he described how he got these data. He hires 3 high school students to scrap from online resources, and he does not have any more ability to collect any more data. So any fields not available in the current data set, he will not be able to recover. And our job is going to build a predictive model to predict the sale price, and I'm going to explain my solution to Neil. And we are going to provide the predictions for the house with missing sale price. First of all, we are going to explain our work using the college circle as an example. At the first beginning, we need to load the data into R, so we are going to load as read CSV here. Secondly, we are going to separate the test set and the training set. We can see that the dimension of the test set is 3035 and training set is 11636. Then we will do is the data cleansing. Notice that the variable log info contains 4 variables: log config, log shape, and log front, confront, and log the area. So we are going to separate them. Here's the code. Below it, we are going to show the code of how I did it. So let's see the log info. Here's the Excel. The log info. Okay. The log info is here. We can see it has 4 sub-variables under the log info. So we are going to separate the variables log info and the similar situation for the variable exterior. So for exterior, let's see, it's here. Yeah, it has 3 sub-variables under the variable of exterior. So we need to separate them. This. Okay. Now we are going to change the data type of new variables. So the dimension of the college circle training set is now 11641 and test set is 3040 right here. Data cleansing. We are going to look for any duplicate records. If the entire record is exact same, then we are going to assume that these are duplicate records, and we are going to keep one of them. And also, we notice that there are 2 houses in which the year sold is earlier than the year built. We are going to remove them from the analysis. So is there any outliers? What about any missing values? This is going to be an issue we are going to talk about later. So any outliers, we are going to check the variable for the sale price of the house and living area. So we check the plot here. We see there is no outlier. So we are going to keep all the data as a reasonable data because there is no obvious outliers. For missing values, before we handle the missing values, we combine the test set and training set and check how many missing values are there and how many percentage they are taking. So we can see it is how we check it. And then here is going to be the percentage of the missing values in each quantitative variables. Okay, so for quantitative variables, we see, okay, here is the 20%, 4%, 15%. So right now we are going to use a median to fill the missing data. Let's take the lot frontage as the example. So it is how we replace the missing value using a median in this lot frontage variable. And we are going to fill in all the missing values here. Since it is a quantitative variables, they are going to have a median anyway, so we can always be able to do this. So for categorical variables is that, we are going to use the NA to fill in those missing values in the categorical variables because they are basically always some, it's always some type of the category we can select from. So we are going to use NA to fill in those missing values. And right now we are going to do the data analysis. So first of all, let's do the descriptive statistic of sale price. We will check the descriptive statistic of sale price and see whether it is normal distribution. So here is the mean value, standard deviation, minimum, maximum, and the quantiles. And if it is a normal distribution, it's going to look like a bell-shaped center in the middle. It's going to something look like this. Well, we can see that it doesn't fit the normal distribution perfectly here. And then we can see, okay, the plot of sale price, okay, the skewness is 1.149 and the kurtosis is 3.615. And the plot is skewed obviously, and it's actually sharper than the normal distribution, right? So the sale price is not exactly normal distribution. But here, let's consider this sale price. After the consideration, we are going to try log transformation to the variable sale price. The plot below fits the normal distribution well. Okay, so here is actually the log sale price. Log sale price. Okay, we can see it's actually reasonable. It's actually a reasonable fit to the normal distribution, something like that. Okay, I see. Okay. Yeah, it's actually a reasonable fit to the normal distribution. And we can see the skewness of the log sale price is 0.047, and the kurtosis is the sale price is 0.45. The kurtosis is it's going to be 0.45, so it's actually a reasonable fit. And right now we are going to select the most important variables and rank their importance using the random forest. So we can see this is random forest, and then after we run this code, we have 12 most important variables. So overall quality, overall conditions, fallbacks, and etc. 12 most important variables. Next, we will select we'll decide which model should we use to estimate the sale price of the houses, right? So we can choose between the linear regression, ridge and lasso, and the random forest regressor, and the gradient boosting regressor, as we are and linear as we are. So we have a couple of choices that we can compare the output. Right now, let's say which model is the best. We can just compare their errors and compare their outputs. And right now, because we want to minimize the RMSE, we are going to choose the GBR model because the GBR is actually minimizing the RMSE. So we consider it is going to be the best model. So we want to see how good the GBR model is. We take the 20 samples to predict the price and evaluate the error. So here is a relative error. We assume, and I think it's actually a reasonable error, and I think it's okay output. So the relative errors, I think it is okay. So we are going to go with this GBR model. Okay, so it is how to do it. And right now, here is the final result. The house ID is this until the 67, and sale price is a result from the GBR model prediction. So it is a house prediction. And I think it's I think to me it's a reasonable. It's actually a reasonable outcome, and I think I like this output. Thank you for your time.